Hello everyone. Thank you to all who submitted entries into our first Game of Apps coding challenge. It's great. It's great to see all of your submissions. Today we're going to go over a few of these submissions just to provide a little bit of feedback and critique. We're not going through all the submissions, so if you don't see your submission here, don't worry. It doesn't mean that it's good or bad. We just selected some that we thought would be good to highlight some specific things that we wanted to show. So again, thank you all for your submissions. So first off, the problem was this. We gave you a specific coding problem where you needed to go through a file and look at each line. We already provided the code to read each line for you, so then all you needed to do was to put some code into this function, get last word length, where we provide you a string that represents one line. So this get last word length would be called multiple times, one for each line. And then in here, you're supposed to put in the code that would then find the last word in this line and then count the number of characters in this last word. But you can't count some specific punctuation characters that we've provided here. Okay, so let's take a look at some entries here. So the first entry here is from student E. I'll just walk you through quickly what it does. So basically, student E will walk through the entire line from the beginning to the end, and then whenever it hits a space, then it'll declare that that's the start of a new word, and it'll reset the word length count to 0. And then it starts counting the number of characters after that. If the character that it sees is one of these punctuation marks, one of these 6 here, then it won't count it. Otherwise, it'll increment word length and then it'll count that. Then at the end of the for loop, it'll return the value of word length, and that should be the answer. And so this is correct. It works fine. So what I wanted to talk about here is that this is very logical. This is probably a very simple way of how we would think, how we would evaluate the line if we were to look at it, right? So, this section here, if line.char at I is equal to space, that basically resets the count. Word length starts off as 0 here, so it'll count the first word, and then as it gets to each word, it'll reset the count to 0, and then it'll count the characters for that word. Now, if it encounters any one of these punctuation marks here, it won't count it. So that won't be counted. Otherwise, it'll count all the letters until it either hits the end of the line or it hits another space, in which case it resets the count back to 0, and then it starts counting again. Okay, great. So yeah, this works. My critique here is that there's a lot of duplicated code. If we take a look at all these else-if clauses, so all these else-if clauses here, there's 6 of them. They all look very similar, right? And they're all basically doing the same thing. They're checking to see if it's a punctuation, and if it is, then it won't count it. And the other thing is inside each one of these, it has the word length plus equals 0. That actually does nothing. So this code is superfluous, right? If it doesn't add anything to word length, then there's no need to show that here. So let me show you a more concise version of the code. So I just made some changes here. So it's exactly the same algorithm. There's just one main change, is that all those else-if clauses, I've consolidated it here into one, and I've used I've checked to see if it's not equal to these punctuation marks, and it's a whole bunch of ends. So basically, if the character is not a dot, and it's not a comma, and it's not a question mark, so it's not any of these, then we will increment word length. Otherwise, we don't have to do anything, because if it's one of these, then we're just not going to increment. And then we still keep the resetting of the word length to 0 here. So yeah, this works. So the main takeaway here is that if you see in your code a bunch of stuff that seems to be repeating, like this one here, and if it's repeating a whole bunch of stuff, then that's a candidate potentially for for the code to be simplified, right? So you don't want to duplicate code if you don't have to. Okay, great. So now let's take a look at the next one, student J. So let's walk through what student J does here. So what student J does, at first, student J defines a whole bunch of variables. So these ones here. Line length, which is the length of the line, how many characters. The start of the last word, initially that starts with a -1 value. The word length, which is not initialized, and ignore char count. And then student J then goes in the for loop here. Student J actually starts at the end of the line. So student J starts from line length -1 and goes backwards until it gets to I is 0. So what student J does is starts reading the characters from the end of the line backwards, and it counts the characters, and then when it gets to a space, so here if character is white space, then it marks the index of the start of the last word, and then it breaks out of the for loop. Otherwise, the code here checks to see if the character at the current index, if it's one of the punctuation marks. So this is a function that student J has provided. Basically, it checks to see if it's one of those punctuation marks. If it is, then it increments a counter called ignore char count. So it basically counts the number of ignored characters until it gets to the start of the last word. And then the last thing it does here is that it does the calculation. The word length is the total number of characters in the line. Subtract the start of the last word, so the index and then subtract the ignored char count. So this works. This code works. My critique here is that it's a bit verbose and a little bit hard to understand. So the algorithm is keeping track of a whole bunch of things, and it actually doesn't need to keep track of that many things. So let me show you a little bit of a more concise version here. So here, all we need to do is just keep track of one counter, which is the character count. Okay, so the for loop still goes backwards from the end to the beginning. And then when we hit a white space, then we break. Okay, so what this is the end condition for the loop. So the loop, we can either get all the way to the end of the for loop, or if we hit this end condition, which means we find a space, that means we've already gotten our last word, then we don't need to go to the end to the rest of the go through the rest of the for loop, and we break out of the loop. So that's an end condition. So because it's an end condition, I'm leaving it on its own if clause, and I'm not joining this other if clause as an else. Okay, it's a completely separate if clause, if statement. And the reason for that is because we want to make it very visible that the first one is catching the end condition for the for loop, while the second if statement is actual logical processing that we want to do inside the for loop. Okay. And then here I've changed the logic a bit, and I do if it's not should ignore. So that means if the character is one that we should not be ignoring, then I increment char count, and that's it. So we don't have to keep track of punctuation marks or anything. We just have to count the valid characters. Then at the end we return char count. Okay, so it's a lot shorter, I think it's a lot easier to understand and more readable. But one good thing that I like about student J's implementation is this algorithm is probably the most efficient one. The first one we looked at was starting to count from the beginning of the line. We count each word, and then when we get to another word, we have to reset. So we're basically throwing away the processing that we've done. With this algorithm where we start counting from the end of the line, we don't have to throw away anything. Everything that we're doing counts towards the count, and once we hit the first space, then that's it, we're done. So this is probably the most efficient way of doing it. Okay, great. So now let's move on to the next one. Okay, so this is student W. So student W, let's walk through what the student does. So the first thing this does is it takes the whole line and splits it up into words. So basically it marks where each space character is, and it's split up into words. And then that's stored into an array of strings, and the array of strings is called words. Okay, so that's really great. One line splits everything up. The second line, it then looks at the last index, words length -1, the last index of the words array, and then that's the last word. So again, very simple, very easy to understand. And then in the for loop, it goes through all the characters in the ignore these char, and then it looks for each one of those characters, the punctuation characters, and it replaces it with an empty string. Okay, and then it returns the once the for loop is finished, the last word will have all the punctuation stripped out of it, and then the length of the last word is the answer. So this works really well. Very good solution, very easy to understand also. The main nitpick I have is this part here. So an empty string plus C. What is that? What the author here is trying to do is, the author is trying to do a type conversion, because C here is a character. Well, this replace method requires 2 strings. So since C is a character, this author does an empty string plus C to basically do a type conversion from a character to a string. Now, I understand what you're trying to do, but there's a lot better ways to show a type conversion. One is the string.valueof can convert a character to a string, or another character.toString. And I think I actually have, I think I show that here. Yeah. So there's a few better ways to do this. Now, so character.toString, this makes it very clear. When I see that, okay, yes, you're doing a type conversion from a character to a string. Okay, that's better than this, because when I see this, I have to stop and think, what's the author trying to do here? Okay, and one other alternative, which might even be better, is there's actually another version of the replace method that takes in 2 character parameters. So instead of 2 strings, it takes in 2 characters. So then we just need to pass in our C and then replace that with an empty character. So yeah, so either one of those 2 would work, but these 2 alternatives is definitely much more readable. Okay. Okay, let's go to the next one. Okay, student F. So student F here, I didn't show the whole submission for student F, but what I wanted to show is this. Student F actually, so this down here is the array that we provided. So the array that we provided with a list of all the invalid characters. So what student F did was they actually added a bunch of other additional punctuation marks. And it's probably because they thought, well, these punctuation marks are not enough. There's actually more punctuation marks. But two points here. The first one is that this addition here is not all-inclusive, because we have, for example, the right round brace, the right square brace, the right curly brace, but we don't have the corresponding left one. So if the right square brace is not valid, how come the left square brace is valid? That doesn't make sense, right? But secondly, which is more important, is that you shouldn't just unilaterally decide on your own that you're going to change what characters are allowed and what characters are not allowed. This was given to you as a set of requirements, and you basically changed the requirements. And although this worked because in the test data set that we provided, we didn't have any of these characters. But if, for example, we provided an alternate test data set with the right round brace, then this would have provided the wrong answer. So it is a bug. what you need to do is, if you see a set of requirements that don't make sense, you look at our set of punctuation marks and go, there's actually more than these. Then you should come back to the user, come back to the customer, come back to us, the author set of requirement, and say, is this what you really meant? Are these the only 6 characters that you want to ignore? Because there's more punctuation characters. And either we'll say, oh yeah, we missed it, and then we'll talk to you about it and let you know what the complete set is, and you can provide input at that point so we can have a discussion. Or we could say, actually, no, this is exactly what we meant. But either way, you should be talking to us before you make a unilateral change like this. Okay, I've seen this happen many times in production code, where the developer just makes an assumption, and rather than making that assumption, that developer should have validated that assumption with the end customer. Okay, so that's student F. So here, student X and Y, two submissions had very similar solutions here, and they use what's called a regular expression. So this phrase here, with the, so the / P and then curly brace punct, that's a regular expression. And basically that says, it provides you with a list of all the different punctuation marks. Now, when you ran this, the answer it gave is wrong. Okay, because in our requirements, the dash was actually valid. This code here removed the dash because you took all the punctuation characters and those were ignored. So, but what I wanted to show here was a couple things. One is that you changed the requirements similar to the previous example. You decided to exclude more characters than we wanted you to exclude. But the second thing is that you're using regular expressions, and regular expressions, a number of you actually had regular expressions in your submissions. And I wanted to say a couple of things there. One, regular expressions is very cryptic. So in the industry, we very seldom use regular expressions. More often than not, we would shy away from using it, and it's because it's so cryptic. And because it's cryptic, it's hard to understand. You have to think again, what am I trying to do here? Someone else who's reading your code has to stop and kind of review again what's happening here. And because it's so cryptic, it's very easy to introduce bugs. So because it's so cryptic, you probably should be commenting. So you put in your regular expression, you should comment what you're trying to do here. So what this regular expression is doing. But you have to be very careful too, because I've seen it where you have a code that has a regular expression. There's a comment above it that's supposed to describe what that regular expression does, but the comment is wrong. So that the comment doesn't accurately describe what's happening in the regular expression. And someone else who's looking at this code, another one of your colleagues who's inspecting your code, they may not necessarily catch on. Because when they see a comment, they think, oh yeah, that comment is right. But if it doesn't reflect what the code is, it's hard to catch. So for those reasons, because it's cryptic, we hardly use it. Now, it is a very powerful construct, but maintainability and correctness is a lot more important than using powerful capabilities. Okay. All right, so let's jump to the next one. This one here, student A, they also use the regular expression, but this regular expression is actually easier to understand, right? You see here that it's basically just a listed, an enumerated list of all the possible punctuation marks that we want to ignore. And so this one is easy to read. And what it's basically doing, let's walk through that. It goes through each line and replaces every instance of these 6 punctuation marks with an empty string. And then it uses the substring method call to get the last, to basically break up the line into words, and then using the space, and then the last item in this. In the last word would be assigned to this last word here. Okay, and then these we really like, and a number of you have done this too. These two systemout.println shows us that you were actually wanting to visually validate that your code is doing what you want it to do. Because when you run this, it'll print out the word. So before you submitted it, you presumably looked at all the printout and go, yeah, that looks right. Every word that I'm calculating, counting looks right. So kudos, that's a good example. Okay, one final example I wanted to walk through here. This is from student M. So student M is very similar. It splits the line using the empty string to split each line into an array of strings. And then it takes the last one and assigns it to last word. And then in the for loop here, the code goes through from beginning to end and basically looks for each one of these punctuation marks. And here, last word dot index of if it finds one of these punctuation marks inside the last word, then it'll replace that with an empty string. So basically, it's removing every single punctuation mark that it says from the last word, and then it returns the length of the last word. Okay, so that's what this does. Unfortunately, the answer that this provided is wrong. And the reason it's wrong is because there's a bug here. This comparison here, greater than 0, was incorrect. And the reason it's incorrect is because ignore these character index of returns -1 if it's not found. If it is found, it'll return the index where it's found, and it starts from index 0. So the value 0 is a valid index. This should be a greater than or not equal to -1. So that was a bug here that was introduced. Okay. Now, what I wanted to point out here is that this might have been avoided if you had actually done the system.println, because then you would print out every word, and then you would easily see that one or more of these words would have an additional punctuation mark that was not ignored at the beginning of the word, right? So at index 0. So if you did that printout, you would have seen that. Then you would go, oh, something's wrong. Then gone back to your code to try to debug it. So the takeaway here is that don't hesitate to use system.out.println to be a part of your debugging toolkit. I use it all the time. It's a very, very simple and easy but very powerful way to debug your code, to validate that your code is doing what you expect it to do. All right, so that's it for today. I hope you guys enjoyed it and that you got a lot out of it. I always get a lot when I look at other people's code, even if it's right or wrong, if the code, because I get to see what's their thinking process. And it could be different from mine, and that expands my ability to code and think through different angles. And so I hope you do that too, looking at each other's code and doing that evaluation and gleaning out of it what you can. And all right, so I'll talk to you soon. Have a good day. Bye-bye.